All right, machine learning exam 1 review. First few questions are about Python. And actually, the best way to learn what's going on is to just type these things into Python and figure out for yourselves, okay? But let me just still give you some more context here. This operator is AND, and this bar here, that's OR, okay? So the first one, let's look at here. A is 1 and B is A plus 1. So what is B? 2, right? So A equals to 1 will become true, right? So A equals to 1 will be true, right? And B equals to will be true, okay? After you execute this, this is what you're going to get, right? So knowing this, let's track A equals to 1, that's true, right? So A equals to 1 is true, and not B equals to 1. Well, B equals to 1 will be what? True or false? False. So not false will be true. So that will give you true and true. Now the AND operator only gives you true if both are true. So finally comes out as true. Okay. So when you print, the first part will give you true. Now let's look at the second one. A equals to 1, or not B equals to 2. Is B equals to 2 true or false? True, B is 2, right? And because you put not, this is going to be false, right? Also, the first part we know that it's true, so this is going to be evaluated as true or false. But what does the OR operator do? Yeah, if any one of them is true, it becomes true. Or that's what OR does, right? If both are true, it still gives you true. True, false gives you true. False, true gives you true if the operator between it is the OR operator. Okay? Second, this is about two different usage of the plus operator. So first of all, if you have integer of two integers, plus just does the addition. But for example, if you had 17 plus 3, when you have quotes around, that treats these not as numbers, but this 17 is going to be treated as a 2 letters. It's a string of 2 letters. So what it does is it will just concatenate the two things. Okay. So that's what the second part will print. However, for this one, an error occur because integer of 3 is error, because 3 is not a number, right? The int function can only convert letters to numbers if all of these are digits. Okay, if you have a non-digit character, then it just gives you an error. Okay. Okay, so this one is about how some methods. So when you have a dot with something, that's called the method of an object. So this is about what the replace method does. And simply put, it just replaces one letter by other. So this replaces F by B, because if you do dot replace F B, it just simply replaces F by B. Okay. However, the most confusing part of using methods in Python is that there are basically two different behaviors of a method. Some method will do something and give it back to you, and some methods will just do something on the object that you changed. Okay. Um, so for example, uh, if you have a list equals to something like A, B, and then if you do, let's just say L. If you did L dot pop, let's say B, this one doesn't return anything but processes L so that L is now L equals to just A. Oh, no, no. This is not a good example. Delete. It's better. Okay. So you can see that this delete method for lists just process the list and it doesn't do anything. It doesn't give you back. But for strings, any method you apply doesn't change the A itself. A still stays as frigate, but B would now be assigned the one that's changed, which is the brigade. Okay?
It would be B.
Hmm?
It would be B. For the answer.
Oh, yes. Sorry, I forgot to say the answers. Yeah, so the answer for this one would be B would be the answer. Thank you. Yeah. Yeah, I should have said the answers. What are the answers here?
It would be
This true for the question one, and this one would be E, the area worker. Okay. So and three, the answer would be B. Okay, but it's important to distinguish these kind of methods. Anytime you use a package, sometimes the commands will change the contents of the object that you operated on, and sometimes it will return a new object. And actually, in some sense, returning a new object is better because, well, there are reasons why that's easier, but yeah. But then returning a new object every time will make a new object, which will make more stuff in the memory. So that's a problem. Okay. Number four, answer is answer. Ans1 is answer. Ans2 is cat. If ans1 is equal to ans2, print you are correct. Okay. Now let's see. Is ans1 same as ans2? No. So what would line 3 evaluate to? False, right? It will nothing print, right? Okay. But this is actually sorry, this is a bit small. Yeah, why is it an error? Yeah, that's you got it. See, writing code is tough because little mistakes like this ends up giving you error. What's the error here? Yeah, you have to say if ans1 equals to ans2. That's the proper way to see if two things are equal or not, right?
Just assign answer
Yeah.
B answer.
Right. So yes. So ans1 equals ans2. If you just simply do this, then in coding, equal sign is not the mathematical equal. See, one thing that confuses a lot of people is that in coding you have something like a equals to a plus 1. You've seen lines like that, right? And they're majorly, people who see this for the first time are majorly confused because it's never true that a and a plus 1 are equal. What But if you understand that this assignment operator really means that A would have this new value A plus 1. So you have this A plus 1 computed, and this value is being stored into A. It's an assignment operator. In other words, equal sign is an assignment operator, not mathematical equal. This is very important. So if you want to have mathematical equal to see if it's true or not, you need this equal sign. Okay, that's the correct one, which means that the answer is B.
We do have the equal, it would not have an error.
It won't have an error, but it wouldn't have anything printed out. Yeah. Yes.
Because double equals Boolean.
That's also true. Yeah, I said it as if the double equal sign is a mathematical operator, but that's still not true. Double equal sign in coding is a Boolean operator. Yeah, you're right. You're right. Yeah, yeah. I can't think of the actual equal operator that corresponds to the mathematical one. Yeah. So, all right. Next. Oh, this is so small. Let me increase this. Okay. A equals to 0. Numbers are 3, 5, 10, and 8. For a number in numbers, A equals to A plus num, print A. Okay, let's keep track of this. First of all, what does the 4 do? Line 3, 4. It's a loop. It means whatever that's indented inside gets repeated multiple times, right? Okay, and initially A is 0, and this for loop will just repeat this line number 4 because that's the one that's indented many times, and then it will first the num will fetch number 3 from this numbers list. Numbers is this list 3, 5, 10, 8, and from this list num will fetch the first number 3 and execute this, which means 0 plus 3 is computed, and that gets stored in A. So A now is 3. You get that? And now it repeats. It fetches the next number, which is 5. 5 plus 3 gives you 8. 8 plus 10, 18. 18 plus 8, 26. So you end up with E, which is 26. That's the correct one, okay? Next, when num becomes 10, right before line 4 is executed, what is the value of A? What about right after line 4? So it's asking what happens before and after line 4 when num is 10. So when num is 10, so far A will be 3 plus 5, which is 8. And then 8 plus 10 will give you 18, and that gets stored. So before it will be 8, and after it will become 18. So for number 5, the answer is E. Number 6, the answer is D. Okay, same question. But now let's think about the following. What happens if line 5 is indented? It's going to print every time because now the indented will become part of the block, right? So not only line 4 will be executed, but line 5 will be executed as well. If before this print, if you put a tab so this entire thing goes right, so in other words, if this thing goes here, then this will form a block that's inside the loop. So it will print every time this line number 4 is executed. So it's going to print 3, and then 8 and 18 and 26. Those four numbers will be printed. Okay? All right. For this one, let's see. Let's make this one. Okay, this is a long code, but the basic point of this question is whether you know how to use a flag. A flag is a variable that stores usually just two values, but sometimes it might hold distinct values. If it's just two values, a lot of times you would just use 0 or 1 or true or false. Those are the flag. And it just records the state of the program. Yeah. So in my in-person Python exams, sometimes I was asking one to what's an example? Can't think of a good example. Let's say in the numbers guessing game, if the person ever put 97 as one of the answers, at the end of the game, you want to say, hey, you wrote 97 for one of your guesses. By the way, that's my favorite number. Let's say you wanted to do that at the end. Then the way you do it is put a flag in the beginning and say it's false. But then anytime the user inputs a number, you have an if-then statement that says, check if it's 97. And if it's 97, you change the flag to true so that after the game is played, the last line will check whether the flag is true. Then if it's true, then you print something additional. So it keeps track of something that happened or not. It's a very good way to keep track of things. Okay.
You would say flag is true.
Yeah, something like that. That'll be like one of the approaches, right? Okay, so flag true. Yes. This will give you error. Why do you think this will give you error?
No, not error. We never run fun. We have flag is true. We have our 3 functions, but we only use bad.
No, there's a print fun at the end. Yeah. So bad and fun are both used. Okay, so global flag makes sure that it's using this flag variable that's defined outside. If flag, return today is nice. If else, return today is horrible. Okay, so what would the fun do? If it's executed right away, then it's gonna print today is nice, right? But then I have a second function, global flag, and I change the flag to true. I here define bad, global flag, I've changed the flag to false. So now let's see, what happens if I do bad? It's going to go back. These are functions, so bad function will be executed. And what does the bad function do? It takes the flag and makes it false. So now the flag is false. Now we have to print fun. Okay? What would it do? It goes to fun and checks the flag. Which one is it? It's horrible, right? So since flag is now false, it will execute the second case, which is return today is horrible. So the answer will be C. Okay? Yeah. Bad in parentheses will execute this function, right? If you don't do bad parentheses, then this will just print today is nice because see def bad only defines the function. It's never executed. Yeah. Yes.
I mentioned before, but for the if statement for fun,
Uh-huh.
I can never actually ask if flag is equal to.
Yeah, so that's a nice way. You could also change this line to flag equals to true, and that's fine as well. Equal, sorry. Yeah, double equal. Flag equal to true, we'll do the exact same thing. Yeah, yeah. Yes. Line 14, I just answered that this executes this function. Yeah, if line 14 is not there, then we only define flag as true, but never changed it, right? So that when fun is executed, the flag will be in the state of true, which will return today is nice. See, all these things, define fun, define good, define bad. These are function definitions. They're never executed unless you call them. Okay, functions are never executed until you call them. Okay. Any other questions?
Just to go back to the test in the game,
Mhm.
you obviously would have to like flag is it true, and within your loop of your yes or number, you have to have a global flag.
Okay. The question is, do you need global flag if you're just using loops? And the answer is no. This one, I was hoping that you would learn something like this in Engineering 120. See, because when you define functions, there's something called the concept of a local variable versus global variable. If you don't put global flag, the functions don't know about the flag variable, even if it's right over it. So line number 1 says flag is true, right? If you don't have line number 3, then when we define fun, it's going to create an error saying, what is flag? I don't know what that is. Yeah. Because inside the function, it only uses local variables. Okay, what will be the value of flag after the program is run? Of course, it'll be false. Okay, the above code will print, sorry, you don't have enough money. What is the value of money after execution? Okay. So let's see what happens. Initially, money is 32. And then the prices are 25, 11, 12. It's a list of these numbers. And now we have a for loop and item price and prices. So it's going to just the line 4 through 6. This much is the indented block inside the 4. So that much is going to be repeated as item price fetches these numbers 25, 11, and 20, 12. 20 and 5 and 11, 12. Total of 4 different numbers. So this red block will be repeated 4 times. Okay? Now, let's see. Money is money minus item price. So when 20 is fetched, what happens after line number 4 is executed? Money will be
Money would be
12, right? Money will be 12, right? And line number 5, it checks if money is less than 0, and it's not. So 6 and 7 doesn't get executed. And now it goes back, and item price will fetch the next number. Which one? Yeah. What's the problem? I see. So first of all, I don't. It's so small. You think it's decimals, but there aren't any decimals. Yeah, it's commas. Yeah, but I do know your concern. So if you are coming from Java or what is it, C++ background, you're not permitted to just simply do 30 minus 20, 20 point. If 20 is a float and 32 is an integer, you have to convert one to the other, but Python is not that strict, and so are many other languages like JavaScript. It's okay, Ruby. It's okay, R. It's okay. So that doesn't have a problem here. Yeah. All right. So going back, item price first fetch 20, subtracted, now the money becomes 12, it's still positive, so 5, 6, 7 gets ignored. Comes back, item price now fetches 5. Now what does it do? Money was
-5.
12 minus 5, so what's the new value of money? 7. Is 7 less than 0? No. So it goes back and fetches the next number. What does item price become now? 11, right? And then when item price is 11 and money is 5, 5 minus 11, you get?
7.
Sorry. 7 minus 11, sorry. 7 minus 11 will be -4, right? So money will be -4, and then it is negative, and it says, sorry, you don't have enough money, and you break. Okay? So that's what happened. And after this is executed, what will be the value of the money? -4. So that's what you have. All right. Any questions? Yes.
Say that even if you have zero,
Well, because it's okay. If you have $0, you've managed to buy everything with all the money you had. Yeah. Yeah. Yeah.
so if there was a customer
You could, I mean, if you don't want zero money, then you could put less or equal to, but that's not needed. Yeah. Yeah. Right. Oh yeah. If it's equal to 0, yeah, stop buying anything more. You've used up all your money. Okay, now starting from 11, these are the ones that we went over in class. Pretty straightforward, right? So, okay. So, which of the following allows you to view the first 5 lines of the pandas data frame? Head, yeah. We've used this a lot, right? Now, a data frame DF has columns weight, manufacturer, year. If I want data frame DF2 to be only the data from year 2021, which is the correct expression? D is the correct one, yeah. Yeah, these are, you can just try them all. But if you wanted to understand what's going on, here's what it does. This thing DF equals to 2021. As you know, the double equals is a Boolean operator. It will return only true or false. So if you have DF DF year equals to 2021, it will return a bunch of true and falses. Okay. And when you have this list of true and falses and you feed it back into the pandas data frame, what it does is only the lines that are true is returned as the new data frame. And that gets stored into the new data frame DF2. That's how this code works. Okay, so if you understood this mechanism, then you don't have to just try to memorize it. It's easier to just understand what's going on. You first check whether the value of the column year is equal to 2021, and it's going to give you a bunch of true and falses. And then when you DF with the square bracket, put those true and falses, it will only return the true lines, and that gets assigned to DF2, right? Okay, number 13 is about the correct usage of the replace function. This is what I meant about earlier, that some methods return a new object and some methods just act on the already existing object. So A says just df.replace node to 0, replace the s to 1. This would have been true if the replace method was returning, was just acting on the already existing operator, existing df. So, yeah. But then, unfortunately, that's not how the data frame works. In fact, what I'm doing here is something called an operator chaining or method chaining. You're doing like dot and another dot, right? Dot replace twice. That's really convenient when you work with data or when you're trying to make graphs. So it's nice to have this operator chaining, but for some reason, if you don't get the object return, operator chaining is not possible. So, for example, in Python lists, all the methods in Python lists don't return any object back. It just acts on the already existing list, which basically saves memory. But the downside is that because it doesn't return anything back, when you get it, you can't act another method to it. So the method chaining is not available for Python list. On the other hand, method chaining is available for strings. Okay, so A is going to give you something printed, but df will stay the same after this is executed. So that's not what you want. You want to change df, then you have to take this output of the replace and store it into df. Okay, so B is the correct one. Okay? Multiple regression, logistic regression, and support vector machines. Which algorithms mainly is used for classification? Logistic regression. We had a homework for using logistic regression to do what? Digit recognition, right? Yeah, we had like 10 different digits, 0 through 9, and you were able to recognize which writing it was by applying logistic regression. So it's a classification problem that logistic regression solved, right? Now, I have a new homework posted yesterday, which basically asks you to something similar using support vector machines, okay? So that's another way of doing classification. Both give you some kind of decision boundary in the space. Yeah. On the other hand, multiple regression is used for prediction, right? You use multiple features to predict what's going to happen for this target y value. So, therefore, the answer is logistic regression and support vector machines, A. Yeah, what was the homework for number one?
It was like you gave us the
Oh, right. You had to pick a data to make a machine trained to predict the output. Yeah, something like, if, for example, I had the used car data. Some of you were using that. And then using some features, you were trying to predict the price of the car. Yeah, that would be multiple regression. Okay, now I have a bunch of questions now about the objective function, but really, rather than just memorizing this and thinking that it's done, you have to understand what's going on because I might ask you the question slightly differently. So, what does the logistic regression do? Well, the output of the logistic regression gives you probability, right? And you're trying to fit the probability as much as possible to the given data by using this thing called cross entropy. So this D is the correct answer, but you want to say D is, you also want to know that D is cross entropy. And minimizing the cross entropy gives you the best fit, best fit probability distribution. And we talked, I spent some time explaining the math behind this and trying to show you when this function becomes minimized and when that happens, your predicted y hat gives you like the same probability predicted by the proportion and stuff like that. Yes,
Is B the one we were talking about, like the penalty?
we were talking. We'll get there. Okay, yeah, because I have other questions with that. Okay, so yes.
I was gonna ask it. Actually, never mind.
All right. Okay, so multiple linear regression. What's the objective function? It's A, and what it does is it gives you try to get the line or the linear function that has the best fit to the data, where the square, so see, A is mean squared error, okay? And minimizing this means the square distance between the prediction and the actual data is minimized. Yeah. Now, you might want to change this and ask, like, why not, instead of reducing mean squared error, just try to reduce the average error. So the average error will be like 1 over n, sum of absolute value of y minus y hat, which makes sense as well, but the problem with that is it's hard to differentiate absolute value functions. So you can't, if you recall, we were able to get the formula for the multiple linear regression because we were able to differentiate the mean squared error function. We can't do that with the absolute value functions. So that's why mean squared error is used. Let's move on, number 14. Yeah, what do you want us? Okay. All right, number 17. What's the objective function for support vector machines? A. And what it does is support vector machines tries to draw the decision boundary where the distance between the boundary and the data sets are maximized. So I kind of explained that in class, but let me just quickly draw what I mean. So if you have like one set of data over here, and if you have another set of data over here, then you want to draw the decision boundary somewhere here so that, see, if you think about the lines that are parallel to this, so here's a parallel line, and here's another parallel line. I don't like that one. So here's a parallel line going through one point here, and then here's a parallel line that's going through another point here. And the decision boundary that I drew in black is like right at the middle. And the distance between the two green lines it will be the width of the decision boundary. And the bigger it is, it's doing a better job in distinguishing the two things. And I worked hard during the class to show that this boundary width is given by 2 over the norm of the weights, right? So that was what was trying to be maximized, and that means maximizing this would mean that the norm of W should be minimized because if you have a fraction, minimizing the denominator makes the entire thing maximized. And that's why you have this thing in the front. Okay? All right, so that first part, the weight squared, make sure that the boundary that you are drawing has the maximum width. And then the second part right here is to allow some of the points to be misclassified. And the value of C is controls how much you allow for such a thing. Okay. All right. So that's some stuff about support vector machines. You need to have some understanding because you'll never know how I might slightly tweak this question. So just memorizing the objective function enough itself won't be everything. Well, some of them you will be asked, but some might be tweaked a little bit. Okay, and we just did naive Bayes, right? So which of the following is used for naive Bayes? It's D. I explained how, oh, here, this capital D is not what I used in the classifier, but D is like X1, X2, X3. So this is the, like the features. D is the features. So you want to know whether it's a spam or not a spam. Given D, where D is like all the words that was used in the spam. Okay? And you're basically comparing two probabilities. If this is bigger than 1, that means it's a spam. If this value inside the log is less than 1, that means it's a ham. And you take the logarithms because computers are horrible at numbers too close to 0, and logarithms can allow you to still calculate it. Okay. Okay. Now here's a question about precision and recall. So let's try to remember precision and recall. So what was it? If you're, yeah, so if the, oh, okay, if you have the actual values, so you might have actual, so this is actual. Actually, it could be true or false. And over here, this is what's predicted. Okay. So in this true false matrix, what goes in here? True positive. It's actually true, and the prediction came as true, so that's true positive. Okay, what goes here? False negative, because actually it was true, but the prediction said negative, so the prediction is wrong, and it came out to be negative, but it's not true. Okay, false negative means it was actually true, but the machine tested it as negative. Okay, therefore, what goes here? False positive, and here goes true negative. Okay, make sure that you remember this table. Okay, where the actual goes here. Actual is this one, and this is the predicted. If you confuse that, it's going to ruin everything. And then recall is right here, whereas precision is this one. Okay, it's hard for me to write, so let me insert text box. Here is recall, and insert another text box. Here's precision. Okay. And what is recall? Recall is It's a true positive over true positive plus false negative. Okay, so this is a true positive divided by true positive plus false negative. And precision over here would be using true positive over true positive plus false positive. Okay, so after seeing this, you should, to solve this, you will need to basically make this table. Okay, so let's write this table. 50 out of 60 positive samples correctly. So you have 60 positive samples and 50 of them were tested as positive. That's good, but 10 was tested as negative, so it gave you the wrong one. And 35 out of 40 negative samples correctly. So 35 were negative and it was correctly classified as negative, but how many were wrong? 5, because there were 40 negative samples. Okay, so that corresponds to the actual matrix, and that's the performance matrix. And then now you have to do the recall. So what should I calculate? 50 over 50 plus 10, which is 60. Okay, and I forgot what this value is. 833. Okay, so good. So this will be B. I'll give you a bit of time to write this down. Yeah, that's because there were 60 positive samples, right? And only 50 were correctly tested. What does that mean? Then that means 10 were positive, but it was tested as negative. That would be called false negative.
Negative tested as positive.
Yes, yes. So 35 were correctly categorized as negative, which were negative, so that's true negative. Yeah. Whereas 40 minus 35 should be giving you 5. Okay, so in the similar way, let's try to do the next question. It's the same thing. It's the same thing, but now you have the precision. So let's just go back to this slide. So for the precision, what should I do? I should be using this one. So what do I do? 50 over 55. So this will be, yeah, 50 over 55, which is 0.909. So it'll be this one. Okay. All right, now I'm given a precision value and a recall value, and the question is what's the F1 score? Remember, F1 score is like the average of precision and recall, but where you take everyone's reciprocals. Okay, so this is called a harmonic mean. So 1 over F1 is equal to 1 over precision plus 1 over recall divided by 2. Okay. So help me out here. Can somebody do 1 divided by 0.79? Well, it's probably faster in Python too. If you have a Python spider open, just do this thing and divide it by 2. Okay, but what does this give you first?
Give it
1.358. Okay, and then you take the reciprocal of that output. Yeah. Yeah, something like that. Yeah. Okay. So it's going to be B. All right. Okay. This is about whether you understood the conditional probability. there are 4 yellow marbles and 5 red marbles in the bag. We are to pick, we have to draw 2 marbles. That's a typo there. We're to draw 2 marbles at random without replacement. Let A be getting a yellow marble in the first draw. Let B be getting a red marble in the second draw. I want to compute the probability of B if the first draw was red. Which of the following correctly represents this probability? Okay, so if the first drawing was red, is it A or not A? It's not A. So it's either, we now have a choice between A or C, right? And it's to be this or that. Now, but if one of the red marbles was drawn, how many red marbles do you have now? 4. How many yellow marbles do you have? 4. So you have 1/2, right? So the correct probability will be A. So it's a simple question. It's just asking if you understood this conditional probability and this notation about not. Okay, so this one was the log odds function. No, this was the part of the cross entropy. So note that cross entropy is the negative of this entire thing. This is f of x itself is what's called as the log likelihood function. Okay. In class, I showed you that the one with the negative will have so negative f of x. So you can watch that video again. I showed just by differentiating this and looking at the behavior at the end, it goes like this, and the minimum is at C. So when x is equal to C value, then it's minimized. But this is about the negative, since the function that's presented in 23 is without the negative function. It will be now like this. Okay. All right. So yeah, D is the correct one. It attains. We did calculations just to show that D is true. Okay. It's not strictly increasing. And by the way, the domain is only between 0 to 1 because logs, you cannot plug in 0 to logs or negatives into logs. So B and C are easy to see that it's not true. The value of f of x is always negative, by the way, because if you have a log of a value between 0 to 1, it gives you a negative value. So A is wrong as well. You have a question?
I don't know, is that inverse of f of x for the question?
Not inverse, minus of f of x. It's just that if you watch the video that I had, there's a minus in front of everything.
Okay.
Okay, yeah. What is the minimum number of rows of data for a multiple regression with 3 predictor variables?
C.
Yeah. Why do you think it's C? Yeah? No, that's not the question. No. Okay, if you have a single predictor variable, what is single predictor variable? It's like y equals to b0 plus b1x. That's single predictor, right? That's a line. Now, for a line to be defined, how many points do you need? 2 points. So for single predictor, you need 2. What if you have 2 predictors, x1 and x2? I mean, first, what kind of object is this one? That's a plane in 3-dimensional space, okay? How many points defines a plane? 3 points. If you have just 2 points, it doesn't define a plane. There are infinitely many planes passing through 2 points. But if you have 3 points, there's only one plane that's passing through all 3. So for 2 predictors, it will be 3. And therefore, if you have 3 predictors, it'll be 4. So the answer is 4. Yeah, in other words, if you have just 3 data points and you try to ask for multiple regression with 3 predictor variables, the computer will complain. It'll give you an error. Yeah. So 3 predictor will be adding just one more here. So it'll be like 3 plane in 4-dimensional space. And for that, it requires 4 points. Okay, logit is, you just have to know this formula, log of p over 1 minus p. So first of all, odds is p over 1 minus p. I talked about this in class, right? So for example, if you had you were throwing a dice, all right, a coin flip, what's the odds of getting a head? Probability is 1/2, but what is the odds? Is 1 to 1. Okay? Odds is 1 to 1. What's the odds of rolling a 1 when you throw a 6-faced die? Probability is 1/6, but its odds is 1 to 5, right? Okay, so you can see that if you have 1/6, that's p, then 1 minus 1/6 is 5/6. So this entire thing will give you 1/5. So that this thing inside the log gives you the odds. You get that? All right. And then you're doing log odds, so you take the log. So simply what you do is you just take the 0.2 divided by 0.8, because 1 minus 0.2 is 0.8, and you take the ln. Oh, another thing is that usually in calculus class, we use ln for log with base e and capital LOG for log with base 10. But in NumPy and most computer packages, if you just have log, that means it's ln, okay? So using your calculator, you also have to bring your calculator, by the way, okay? Using your calculator, just punch this in 0.2 over 0.8, and you apply the ln function in your calculator. What do you get? Yeah, so that's what's going to happen, right? Yeah, so in NumPy, if you want the common log, which is log base 10, the command is log10, log 10. You have to explicitly put 10 there. Okay, a medical test for diabetes has accuracy 89.4% with sensitivity 88.9% and precision 90.9%. If the test came out positive for a patient, what is the probability that the patient is actually diabetic? Okay, so it's again this problem with true positive, false negative, false positive, true negative. Okay, and then what's accuracy? Accuracy is true positive plus true negative over everything. That's accuracy, right? And what's recall or sensitivity? Is this one? That's recall. And precision is this one. Oh, let me use a different color. Precision is this one. Okay. Now let's look at this case. The patient's test came out positive. Okay, so which of the 4 cases could this patient be? Could he be TP? Yes. Could he be false negative? No. Why? Because test came out positive. False negative is if the actual is positive and test came out negative, okay? This P and N at the end is the result of the test, okay? So this patient could be either TP or Either TP or? No. False positive. He came out positive, okay? This person came out positive. So this person is either true positive or false positive. So this is now about precision. Okay? And what does precision measure? If the patient came out positive, what's the probability that he is positive? Therefore, out of the three numbers, we're using this one. Okay? So A is the answer. Multiple regression was trained on the data using all the available information. How many columns does data have? Okay, so in a pandas data set, you might have, say, if it's a card data, so it might have the year it was made, right? And then it might have the capacity, and then you might have something else, but then you'll try to probably predict the price. Now, what if you just had exactly 3 columns? What do you do with the multiple regression? You would use the year and the capacity of the car to predict the price, right? So this is going to look like the predicted price is equal to B1 times the year plus B2 times the capacity. And then plus what? B0, which is the y-intercept, right? Yeah. The B0 does not require any data, right? Okay. So this is exactly the case given to us, right? It's a multiple regression with 2 predictors, okay? So how many columns should this have? 3. Yeah, I have year, cap, and price. So it's in this example, you see that's 3. Okay? There should be a column for the y, column for the x1, and column for the x2. That's why it should be.
So the B1, X1, and B2, X1 is B0 is the set. Why do we have? I mean, it's just like language. I mean, is that?
Yeah. B0 is needed just because if you want a generic line, you need the y-intercept, right? Yeah. Beta 0, beta 1, beta 2, those are the weights. Those are called weights, okay? X1 is a column, X2 will be a column, Y will be a column. But we're really using the X1 column and X2 column as predictors to predict the target Y. Okay. All right. A multiple regression is now beta goes to beta 3. So it has X1, X2, X3, 3 predictors. Okay. So how many features did this multiple regression use? Features, predictors are the same thing. Okay. So this will be 3 predictors. Features is same as predictors, okay? Yeah. The target is not counted as a feature. The target is, so Y is not counted as a feature. You get that? Yeah, okay.
So 20 also be
Yeah, 3 predictors because now it has X3. X1, X2, X3, 3 predictors. Okay. Well, what about 27? How many predictors does this have? 2. How many features does this have? 2. Okay, feature and predictor, same thing. Okay, here's an interesting question. Multiple regression was trained in a data set, and then it was found that the values of y had to be increased by 2. They measure something wrong. So they increase everything by 2. Okay. Now, if you trained it again, what's going to happen to the coefficients, the weights? Well, think about the following when you just have one feature. So just for the case when you have y equals to b0 plus b1x. So if you have this, that's just a line, right? So think about this case when you have a single line. Now, what does this do actually? In actuality, you have a scatter plot of the data points. Data points is somewhere here. Okay, and it has the values of X and Y, right? Now, if only some of the data are changed, then the slope will change. Do you agree? So for example, let's say they realize that some of here was measured wrong and that they actually should go down somewhat. But these are the other parts are intact. The others are same, but this one has to go down. But then if that's true, then what's going to happen to the slope? The slope will be smaller, right? But that's not the case here. Here you have the data sets, and all the data sets are going up. So this slope, this line will just go up by some amount, right? The slope will be unchanged, okay? So in that case, what's going to change? B0 or B1? Only B0 will change, okay? So that's what's happening in this 29. Only beta 0 is being increased. The beta 1, beta 2, beta 3, the slopes are not changing. So the answer is A. Did that make sense? Okay. Yeah, so like you should also be worried about how I might tweak this, right? So what would be a question where the slopes change? Well, if let's say the data was same, but x1 value, let's say, was using the wrong unit, okay, went from feet to inches, then feet and inches they will scale, right? So the x1 value will scale, so that means beta 1 will change as well, okay? Now, that probably means beta 0 will have to change as well, okay? Because the lines get crooked and then the B0 has to change as well. But if only x1 data has been scaled by linearly, then beta 2 and beta 3 won't be affected. Okay, those slopes will stay the same. Beta 0 and beta 1 will change. Okay. X1 is scaled in a different unit, then beta 1 and beta 0 will change, but beta 2 and beta 3 will not change. Mm-hmm. Yeah. All right, so I only have 3 minutes on this one, so let me be a little quick. The remaining 4 questions are really about dimensions, okay? So, see, if you have 4 or 5, that means 4 rows and 5 columns. 5, 10 means 5 rows and 10 columns. And those are like 2-dimensional arrays, which can be thought as matrices, right? And matrix multiplication is defined only when, only when these two numbers match, then matrix multiplication is defined. So B can be done. Okay. On the other hand, D cannot be done because if you look at D, 4 by 5 transpose will give you 5 by 4, and matrix multiplication is not defined. Okay, this is about reshape of -1. -1 just means that whatever is reasonable goes in there. So because originally data size is 10, then if you reshape by 5 -1, it will become 5, 2. So the answer is A. If you have 12 and you want a row vector, what's a row vector? That's 1 by 12 2-dimensional array will be a row vector, right? So which one does this? The C does it because -1 will be automatically calculated as 12. Okay. So you have to know what the usage of -1 is. Look it up. Okay. If you didn't understand what -1 does in the reshape, please look it up. Last question. If you have a 3 by 4 matrix, what gives you what's the transpose? It gives you a 4 by 3 matrix, right? And if you do a matrix multiplication with the 3 by 4, this matrix multiplication is defined because these two are the same, so they go away, and then you end up with the 4 by 4 matrix. So D is the answer. Thank you.